Hello, everyone. Thank you for joining our talk. Welcome to the AI Showdown open source tools for LLM face-offs. My name is Rishabh Misra. I am a AI and ML engineer by profession, and I work on designing low latency, large scale machine learning and Gen AI systems for conversational commerce domain.
Hey everyone, this is Jigyasa Grover. I'm an AI/ML engineer currently working on user personalization and monetization algorithms. So before we begin, let me ask you all a $100 billion question. How do you actually pick an LLM to power your product? Is it based on price, benchmarking, trial and error, or maybe just copying your competitors? I think all of these options are flawed in isolation. The model you actually choose would impact not only your cost, latency, accuracy, and ultimately the trust of your users. So here's a timeline that shows the releases of various LLMs. It isn't exhaustive by any means, but it does show the relentless pace of releases from some of the major players like Google, OpenAI, Meta, Anthropic, alongside some very powerful open source models from Mistral, Alibaba, and others. So the crux is every week there's another LLM dropping, be it GPT, Gemini, Claude, etc., and they all claim to be the best. But how do you choose? So there's no doubt in the fact that we are actually drowning in choices. This explosion of generative models that we've been seeing is making the structured evaluation process not just something nice to have, but actually an operational necessity. So we all know evaluating LLMs is hard. And it's hard because of several reasons. The model performance actually varies based on what task that you're performing, and also the domain, be it healthcare or finance. And along with that come the fact that there are various hidden failure modes. It's not just the API not responding. It could be like hallucinations, bias, safety, and so many other issues that can crop up. And not to forget the fact that constant new releases keep shifting the bar. There was GPT-3, GPT 4.5, GPT 4.0, GPT 5. Like their models are just coming day in, day out. So, and if you consider only the benchmarks which are being used to score, they rarely capture what is the true essence when you actually apply them. That is the user experience. Those test scores won't guarantee the right tone or usability in practice. So let's say given a scenario, how would you typically start to evaluate? So the first thing is you'll think about the task type. If there's a single correct answer with a reference, maybe like code or unit test, we can use some deterministic checks. But for predictive tasks, let's say classification or ranking, you have typically used precision, recall, or NDCG. But with generative tasks where there is no one single right answer, or maybe there are no references, you can use some overlap metrics like rogue scores, which can be brittle, or some semantic ones like BERT score. But there is another technique that has been emerging very rapidly these days, and it's called LLM as a judge. But before we dive into it, let's think what we have been doing so far till date. So far, we had all been using most of the traditional machine learning models, where evaluation is clean and objective. We had ground truth labels, yes, no, 1 to 5, whatever, and we used to compare those predictions, and out comes a single number. So you could have accuracy, F1, AUC, depending on the task. Now that was not only very fast, but also cheap and fully automatable. But with LLMs, this approach kind of like breaks down because there is no single correct answer to a creative prompt. The quality is subjective, also multidimensional. So the big challenge is how do we make this process, which is very messy, more subjective, scalable, and reproducible? So let's consider these two systems. What we have seen on social media is, let's say, a video recommender system, and often it's a traditional ML problem. The output is a probability score, which can be easily evaluated using PRAUC. But then, on the other hand, you have a contemporary customer support chatbot, which is not a traditional ML problem. So if you see, my order hasn't arrived and I'm furious, if that is what a user types. Now, there could be two different responses. Both responses are actually grammatically correct. Maybe their BERT score in both of these cases would be amazing. But response A is what is building loyalty, while response B might create more friction. So how do you measure that? And not only measuring that for one-off scenarios, but measuring that at scale. And this is why we must go beyond the numbers, beyond the rogue scores or the BERT scores that we have been seeing. Numbers, they do not capture the full story. We need to ask if the output is helpful, is the output safe, honest, and coherent. So we need a system for qualitative analysis that is both scalable as well as reproducible. So I think I've pretty much given a whole crux that the key takeaway is traditional ML evaluation is mostly quantitative, and modern LLM evaluation requires both quantitative as well as qualitative analysis. That is the TLDR for folks who missed. And this is where the power of open source community comes in. Open source isn't just free software. It's what makes trustworthy engineering possible. First of all, it gives us transparency and reproducibility. So there are no black boxes. You can see the prompts. You can inspect the scoring code. You can also version the pipeline. So results today can also be replicated tomorrow. The second thing is it ensures vendor neutrality. You're not logged in to any one ecosystem. You can compare GPT with Gemini or Llama all side by side in a customized manner which is suitable for your task and domain, and actually choose the best model for the job. And finally, it gives you a clear audit trail. The configs, the code, the prompts, the output, everything you need to justify your decision. And I'd say that's not just a good practice, but in regulated industries, it is something that is very essential. So I think I'll pass it on to Rishabh to introduce to you a new tool.
Yeah, so this is where we want to introduce one of the core tools that we want to discuss today, LLM Comparator. It is an open source tool developed by Google's people and AI research team. And its goal is to facilitate rigorous side-by-side evaluation of LLMs, blending the quantitative scores we have been seeing from the traditional ML domain with qualitative interactive data visualizations. The tool was built specifically for the LLM face-off use cases, so let's dive in. Here is the sneak peek into the UI of the LLM comparator. So as you can see from the left, the first three columns have the prompt with side-by-side model responses. So these models would be like different LLMs working on the same prompt and generating different responses. And then in the next column, we have the comparison score from a judge model. Judge model could be anyone of your choosing. But if we see a positive score here, that means the model A or LLM A is working better on the prompt. And if we see a negative score, that means that model B is working better. And then at the very right hand side, we have some analytics where we can also filter various metrics by prompt categories for domain-specific insights, and also get a rationale summary that clusters the judge explanations into various themes. So it is pretty kind of digestive in a sense. You can understand what is the overall themes, where the model A is performing better, where model B is not performing better. So let's dive a little deeper into the entire process. So this is the tool which is provided through the Python package on PyPy and can be installed simply with one pip install command. So there is no complex setup required. And then once it is kind of installed, it can be imported in the in our code, and we just have to run the run judging pipeline function, and that handles the entire evaluation workflow. So now let's walk through what happens like behind the scenes as we go through the evaluation workflow. So the process would begin with the prompt set. So think of these as your test cases. So let's say you have 5 different prompts where you wanted to compare 2 different LLMs. So that will constitute of your prompt set. And this is where you want to attach some additional metadata that will be critical for evaluating and creating different slices of the results. Once we have set up the prompts that we want to test out, we will get model outputs from different LLMs that we want to generate responses from. So these would provide some pre-generated files, or you can have the libraries built-in model helpers fetch the responses live from various APIs like Gemini, Claude, and so on. Or even you can host your custom local models. So all of that is pretty much like customizable and plug and play. Once we have set the prompts and the models we want to use, the next phase would be the judging phase to automate the very difficult process of producing qualitative review of the LLM responses. So this is where we'll in this case, we'll use LLM as judge, which is where some of the very powerful models like Gemini can emulate human preferences at scale, but we can also use human judgments, but those will have to be loaded through a separate file. The output of this phase would not just be one single score of which one is better or which one is worse, but it will be scores plus additional like rationales. So for every comparison, we get a decision and a free text explanation of why a certain model is better. In this phase, one critical thing to highlight is that LLM Comparator incorporates features to mitigate various known biases in LLM judgments. So there are 2 specific parameters. First one is flip position parameter that would randomize the order in which the responses are presented, because LLMs would usually treat the first response as better if we don't like randomize it. And then we also have a parameter around deciding the number of judges. So we will try to run multiple trials of the same experiments that will kind of make the final score more robust and reliable. So these are some like critical additional parameters which are available in this tool, which make the comparison fair and more robust. Then after we are able to run the judging pipeline, what we'll get as an output would be the raw rationales, which could be a little bit verbose. So the next set of steps will try to bulletize the various outputs that we have gotten from the judge into some clear bullet points, making it like much easier to digest. And then after that process, we also have this cluster step that is gonna group semantically similar bullet points together. The goal there would be to consolidate the themes and see what are the themes emerging across different evaluations, which could help us understand which model is consistently winning in certain dimensions and which model is losing in certain dimensions. So that just helps us understand the overall evaluation process a bit better. And then all of this, the inputs, the scores, and the clustered rationales are compiled into one single file, which is called comparator.json. So in this file, we think of it as a self-contained like replay tape for the entire LLM comparison and the showdown. So you can check it into Git, share it with colleagues, or archive it to track model performances over time. So it is one single artifact which will have all the details. It is broken down into 3 parts. First one is the metadata. It will capture the entire setup, prompts, the models you have used, the judging model you have used for full reproducibility. And then the second component would include the results, which will contain the detail per prompt data, the model responses, who was the winner, and the rationale behind it. And lastly, it will contain some aggregated scores in the summary and overall winner for a quick overview. So getting this overall summary is good, but finally we want to like visualize this in an interactive UI. So that was the UI that I kind of first showed. It is just like rendering all the results which are presented in the comparator.json file. And this allows us to seamlessly move from like a high-level aggregate view of win rates and score distributions to individual prompt level comparisons and judge explanations, completing the overall life cycle. So overall, the LLM Comparator tool will let you move beyond the simple leaderboards and truly understand the nuanced trade-offs between the models for your specific use case. So just checking on the time, we do have a little bit of time. We can go through this link quickly and then just quickly see how it is like in action. So typically when you open the link, this is what you'll see. This is where you'll load your comparator.json file. But just for the demo, we can go through one of the existing results that we have. So this is the tool in action. So let's say the prompt is what is LLM comparator. You can see the first model is giving a little bit like better response. It is like more comprehensive, and B is a little bit shorter. So the model score is positive in this case. That means like A is better. But you can like drill down and understand overall word counts, the bulleted list, how it is kind of formatted, and everything like that. So yeah, feel free to like explore this at your own time, but this could be really exhaustive whenever you're thinking, given like 2 LLMs, like which one should be performing better for your specific use case. Cool. So Jigyasa will continue on other tools that are available out there.
Thanks, Rishabh. In the interest of time, I'd like to say that LLM Comparator isn't the only tool, and it's not as comprehensive based on the process in which you'll be choosing the model, because there are like so many other ones like Eleuther's LM evaluation harness that is more focused on the standard for academic benchmarking. Now, this does not cover benchmarking. So if you want to reproduce a paper's result on, let's say, any of the existing benchmarks like MMLU or HellaSwag, this would be your tool. It's less focused on the interactive qualitative UX, but more focused on benchmarking. If you are more into the whole OpenAI ecosystem, if you're already logged in, then there are OpenAI evals. They are specifically designed around picking models just from OpenAI's APIs, and they're very powerful for production monitoring and regression testing. And similarly goes for Hugging Face evals. If you need to specifically compute the quantitative scores like BERT score or ROG, it's more simple and a reliable choice that integrates well with the Hugging Face ecosystem. And finally, if you are building agents and chains using LangChain, using their built-in evaluators seem like a natural fit, as they are designed to evaluate the outputs of the complex chains that we have. Now, depending on the standard part of the whole LLM integration lifecycle you are in, you might want to choose a different tool. So let's say if I were to pick, my rule of thumb is, for academic style benchmarking, use LM evaluation harness. If I were to just choose 2-3 top candidates from the plethora of generative models available, I would use LLM Comparator. For more ongoing production monitoring and regression testing, if I'm already logged into the whole OpenAI ecosystem, I would go for the OpenAI evals. And lastly, if I am collaborating with a team on some standardized metrics, Hugging Face Evaluate is excellent for that task. But before we wrap up, I'd like to share some tips. Is use judge ensembles and position flips. I can't stress this enough, because that is something that reduces bias that you get. So try to use at least 2 or 3 judges and keep switching their positions. Also keep in mind that do not average, focus on slicing. So overall win rate can sometimes hide very critical flaws and failures in a specific domain. So always check performance on your most important data slices. And that is where the metadata tags that Rishabh initially was talking about in the prompts come in handy. And lastly, it is also important to calibrate the judges that you would be using for this LLM as a judge technique. So before you run, let's say, 100,000 different evaluations on these prompts, take a set of few golden prompts, let's say 10 or 20, which are human-labeled examples, and you know for sure which model performs the best on those golden prompts. And then ensure that your LLM judge is aligned with your quality criteria. So along with that, there are more such tips that I've put it up there, but just in the interest of time. But also be aware of pitfalls. Like, don't always go for leaderboards. Always add domain-specific slices. Now, that is something that, if you take away something from this talk, is don't go for benchmarks or leaderboards. Take your particular use case into account, and don't rely on one single judge. And let's say if your application is using something like tools or function calling, your evaluation criteria should also test that capability, having tool trajectory, or not just text generation. And with that, the field we know is definitely moving very, very fast. We are seeing a more push towards judge ensembles that mix both LLM feedback as well as human responses. So integrate them into your CI/CD pipelines for continuous evaluation. There should be a real heavy focus on safety and red teaming slices as well. And ultimately, there is a push towards evaluation for multimodal models as well that can not only handle text, but also images and audio. So that is all we are anticipating that would be coming up next. And with that, as a thank you gift for everyone coming here and listening to my talk, I'm sharing free access for a limited time only to my 2 LinkedIn courses. So one that is more oriented towards data scientists, AI ML engineers, developers, product folks who want to collaborate together and design ethical, explainable, AI-infused products. It's called Integrating AI into the Product Architecture. And the other course is more hands-on for developers who want to get started with building agents from the ground up using Agent Development Kit, or ADK. And yeah, let's build the next generation of AI-powered products more creatively, scalably, and responsibly. Thank you so much, everyone. Also open for questions, if any. Otherwise, we'll be roaming around here. Go ahead.
I saw you doing A/B testing there. How many models can you test in parallel?
I think for now, it's just between the two responses only. But you can use multiple judges. That helps. Yes.
I hope you can hear me from here.
Yeah.
You were speaking about the judge ensembles. Can you go a little bit deeper into that? Do you recommend any size
I think one of the tip that has been used is like use a judge that is not either of your models, not model A nor model B. And typically, if possible, use something that's more open weight or open source model so that you can look into, again, the intricacies of the model. So these are 2 tips. And there was another one to use at least odd numbers so that you can do tie breaking easily.
Anything about the sizes of these models?
I think that's very much dependent on the use case. Again, it's hard to say on the size aspect, yeah. Welcome. Well, yeah, thank you so much, folks. Hope you have a good rest of your day.